files in the Dropbox.
Which files? Yeah,
Um,
I'm going to place these class files today. Yeah, there was
okay.
some problem with Dropbox. I don't know. Somehow, whenever someone was about to copyright, someone just cut it and pasted the files. So all the files went off, right? So that's why I created a new folder, right? And I reshared it again. So
Yeah.
I'll share all these files again. Okay, all the threading files and all these files. Okay, you can just go through them.
Yeah. The thing is, like, we will be referring it in future, right? I mean, is it? I mean, can you just do save as since we don't have these files?
Okay, so you don't want me to append in the same file?
Yeah. Probably we can create a new class file and then.
Okay, definitely, because I'm not changing anything. I'm just okay. I'll do that. I'll do that whenever there is a major change in class. Okay.
Okay.
Okay. Fine.
Thanks.
Oh, no issues. Yeah. Fine. Yeah. So I'll take boolean and I'll just say lb some a boolean. I'll just say is error file something. So if it is an error file, so it's a very straightforward anyways. String, let us say lstr file path is equal to none something. So based on my situation here, a bln, right, error file. If it is error file, I'll just take it as my file path as this, which is my error text file, right? And if it is not, then I'll take some other path. That's it. Some other path, which is, let us say, I'm taking it as info.txt. Okay. And based on, so whatever you pass, the file will be appended up, right? If there is no file over there, it will create an append, right? Now let's go back here and just say comma, if it is app logger, so it is not an error file, so let's say false here. So here I want to say that yes, this is my error, and I can say that yes, this is not my error, right? So here that's what, and here it is my error log. So I'm just showing you that I'm using the same file here to actually do something called use the same file in different situations here. So I'm just checking out two situations, which is I want to log whatever is an exception in one file and whatever is the information in some other file. I can't create one more app logger. That is not optimized way. No, never do create anything which is separately. Don't create anything here, right? Because if you try to create it separately, again even this will become different classes. Again the maintainability will increase, because you are touching your files in multiple classes, which is not an optimized program. So everything should be done in one program and in one method and one in class, right? Here I'm just using something called boolean to just differentiate two different tasks called, one is in error and another is info or information, right? So in the same way, you may have different logs. You may have batch logs, you may have server logs, you may have like app logs, right? You may have some information logs, right? You may have some thread logs, right? But you can create all those logs in one method here itself. How can you create is just give different flags here. As of now, as we are checking out two different situations, I'm just taking true or false. True for error and false for information, right? You can have any number of cases here where you are giving the same number of stuff, but you're just appending something which is different here, right? Yeah. So here we have done this. Now let me run this up. Yeah. So you can see things are done here. When I see, you can see here only 2 lines got appended, right? Only 2 lines got appended. Let's go back and see in the developed file SAMs. You can see one more file got created, which is info. In info, you can see that application started. Yeah. Using the same program, we are doing something which is logging things in a different file. If you run any number of times, right, go back and see in the file here, right? So all the exceptions, see, all the exceptions will be logged only in error.txt, and all the infos will log in a something called info.txt, right? So this is how we actually maintain in real time. We should write an logger program which should be a single class or a single entity where you are handling the whole logging, fine. So that is what is all about different things in how we log and how we use something called writers, readers and all, right? So now let's move ahead and check out one more decorative pattern. But before that decorative pattern, so we'll see what exactly it is. But let's get back to your so now we are going to talk about something called serialization. Now basically you would have heard, if you are currently in working, right, then you would have heard this word, which is serialization, in different contexts, right? So it can be in serialization is something which will be used in Linux, it will be used in .NET, it will be used in Java, right? It will be used in multiple contexts, the serialization. So mainly, what is the serialization? So serialization is nothing but persisting an object and making it save or making it persist in your hard drive or over the network. So what does it mean again? It is something which is a complete technical term. So let me just explain in layman. So serialization is something, let us say, I'll give you a use case here. Let us say let us take an example of facebook.com itself, right? Where whenever we log in facebook.com, right, which means we are actually giving a username and password, right, and we are clicking on login button. Now, so whenever we click on login button, obviously something should go to the backend, like some message should go to the server, right, which is Facebook server, and they process it. So sending a message from your machine to there. So how do we do that? Because there should be something which is which should be transferred over HTTP protocol, right? So there are so many ways that we can transfer. We can transfer some XML and so many things. But don't bother about that. We'll be learning it in our future classes. But as of now, let us see a case where we are creating a class, a simple class, where whenever a user clicks on login, let us say we are calling that class, we are filling something called username, password, everything, and we want to send it to server. Now can we send the whole object as it is to server? No, we can't, because that object will not be persisted, because that object is not in a form of buffer, and that object is not in a form that is compatible with network, right? For that case, or for that situation, what we need to do is we need to convert the whole object of the class to something called byte buffer, or you can say buffer, and then place it on network so that it will be transferred over the network and the server can get the byte from the network. So that is nothing but we are converting an object of class into something called byte buffer. So for the conversion of a class object or any pointed object in Java to something called byte buffer, we use something called serialization, right? So serialization is an interface in Java. It's a complete interface class, and it is a type of marker interface. So what is a marker interface is, marker interfaces will not have any inbuilt methods. We know that interface is nothing but interface contains all the abstract methods in it, right? There won't be any non-abstract methods in it. But here in this marker interface, even abstract methods won't be there. It will be blank class, or sorry, blank interface. But this interface class is mainly for if you define any class as a marker interface or a serializable class, then you are actually informing your JVM that yes, this class should be supported to persist as a buffer or to convert it as a byte buffer. So then only your JVM will support your class object to convert into bytes. So that is the main usage of your serialization class or an interface, right? So that's what we use serializable class here. And basically your serializable, whenever you are using whenever you are trying to do something called serialization, whenever you implement serialization, right? So there are some rules that should be followed. Anyways, basically the first rule is that it should any class, whichever, let us say Facebook login, let us take an example of login, FB login, right? That FB login class should implement something called serializable interface, right? And one more very important rule is that that class CLS FB login, right, should have a default constructor, which is it should not have a default constructor with a argument acceptance, right? We should not declare that, right? Because internally what it does is, whenever you have something called default constructor, it will internally call something called your serialization class constructor. So that's why you should not have anything about that, right? And these are the very two rules anyways. And we have one more rule called serial version ID. Serial version ID will just understand whenever we are coding in that, right? So, and in order to do all these stuffs, which is using this serializable class, anyways, we are making our class to actually make it something called serializable, right? And we use something called like the declarative pattern, which we use in order to make a class converted into byte buffer, is object input, I can say input or output, right? Stream, right? So these are one, but anyways, these are not the actual. We can say object input stream or object output stream. So you have to use object input or output stream in order to make indexing to your serializable class, in order to convert it into a byte buffer, right? So let's get into the program and we'll see how exactly we can do that, and how we can use this declarative pattern, which is, again, you can see that object input stream is again a very important declarative pattern, which we use for converting an indexed objects into byte buffer, right? Let's go and create a few classes here. Let me just close all. So in files, okay, let me create a new class. Okay, let me just create a same FB login, let us see. So here, let us say I have two things, which is string, let me just say public string. So and anyways, your serializable classes will not have something called methods. You should not have methods, or I can say there is no use in writing a method in a serializable class, because serializable class is something where you want to feed some data, create an object, and send convert it into byte buffer and send it over the network. So for that you don't need any methods over there, right? So let me just take username right here, and let us take one more thing, which is public string password. That's it. Yeah, let's take two things as of now, right? Okay, so I've created a simple class where I have my username and password, right? Now here what we have to do is, we have to, in order to make this class serializable, you have to implement something called serializable class. Anyways, again, you can see here that serializable interface is under something called java.io, right? and you can see whenever I implemented something, it is not giving me any error that you have to implement some method. Why? Because serializable interface don't have any internal methods as such, right? Now here you can see in this FB login it is giving some warning here. So the warning is nothing but this serial version ID. So what does this serial version ID means? This serial version ID is something where, let us say, whenever you log in something, whenever you are actually creating this object, right, you will give some serial ID. So that serial ID will be sent to, let us say, will be saved in a file, or let us say if you are sending it over the network. If you are sending over the network, so in the next phase where your server is actually getting these bytes, right? So that will read this ID, and based on that ID it will map your class, right? We'll see all these terms, whatever I'm saying, we'll see all these things, but here we'll not be using on the network, we'll be using the hard disk here. Hard disk here is, I'll be saving the bytes into some file, and I'll be reading that from different class. So saving here, think that I'm actually placing the things in network, and getting the things, think that I'm actually reading something from stream in a server, right? Yeah. So here, so first we'll create something called serializable class. Serialization. So serialization is, we have to convert our class, fill the things and convert into bytes and save it in a file. And then we'll create a program for deserialization. What is deserialization? Whatever bytes we have saved in a file, right, convert back to object and see whether everything is being persisted or not, right? We'll see that. So let me create the class. Let us say I'll create serialization class. Some class, serializable class. Okay. Now, so in this class, what we want to do is, I want to save a file with the complete byte buffer converting this, right? So now let me just write a main over here. Let me handle the exception. Fine. So here, let us say whenever you click on login, let us say I'm creating this. So first what we have to do, we have to create an object of FB login, which is new FB login here, right? And let us say I am filling up two things, which is username is equal to, let us say, xyz, right? And obj dot password is equal to, let us say, ab, or let us say number 1 2 3, right? We just filled it up. So this part of story is something where you have actually filled your username and password. And now let us see. So now what we have to do is, we have to actually get the bytes of this and save it into file. Now let me create a file first, which is file, let's say f is equal to new file of, so let me take the help of this part. So let me take the same part, right? And yeah, we'll try to create something called let's say FB packet, FB pkt.ser. So ser should be the extension of a serialization file where you want to actually put in all the bytes. I'll show you once we convert this into bytes, once we save some, not bytes exactly, once we serialize it into buffer, and once we save it in a file, I'll show you how it is getting saved, right? And then so now you have to get into the actual thing, which is object input stream, where we want to write something. So we'll go to object output stream, right? Again we'll be using a declarative pattern here. Now first what we are doing is, we are trying to use object output stream. Let us say OS, or let us say LOBJ object output stream is equal to new. Now you can see that this needs, and again, something called output stream. Now we are using something called file again, right? So what we do, we again go for something called file output stream, right? Just say it as f output stream is equal to new. It needs some file again, if you can see here, right? So what we'll take it as f, and file output stream as here, right? So we have created a declarative pattern here, where we are using object output stream, and internally it needs something called file output stream, and we loaded that in here, right? So now here we have to check something. Every time you write something into this file, right, it should be a brand new file, because what happens here, if you try to append that, the old bytes will be affected, right? So that's why what I'll do, we'll just say f dot exists. If the file exists, I want to delete that first, f dot delete, let us say, right? And then we'll create a new file. So anyways, your stream will create a new file, your file stream will create a new file, right? Now here what we'll do next, now our output stream is ready now here, which is pointing to this file, and our object is ready. Now the question is how to get this object and use this object output stream and write it into file. Again, it is a straightforward method in object output stream, which is just use object output stream dot, you have something called write object. When you use this write object, right, it will take any object as such, and it will be loaded into your serialization file, okay? And once you write this, just say lobj os dot flush, and then so once this is done, let us say, let me just write it out. This is how object serialized, right? Just give a name so that we can just start object serialization, right? So yeah, so object serialized, and we're just writing out this, and yeah, so by the end what we have to do, we have to close these things, right? So just define these two over here, which is this, and just say null here, and right, I just click on this thing, so that we are actually increasing the scope of them, right? And now write a finally here, just say file object stream, right? If file object stream is not equal to null, just say file object stream dot, sorry, for output stream dot close. Then if file obj is not equal to null, then say close. We are done with it, right? Now, so let me just go back to this folder and delete all the old files. We don't need any of these files, right? Now get back here. Now we have seen the same program. Okay, we have to add it through. Anyway, it's not a problem, right? Now let me just handle this, which is sysout of some e dot get message. Okay, so that it will show you what exceptions we are getting. Now here, if you can see, the pattern of what I am writing is the same as the thing what I have written yesterday, right? The same pattern, like I've used some output stream, and internally I gave file output stream, and I used some file, and I wrote the same. Here I'm using the same pattern here, same declarative pattern, but here the only change is I'm creating a class, and I'm actually converting the whole object into a buffer. That's it, right? Where I created a class, filled up all the details, right? And what I did is I just wrote all the bytes or all the object as a buffer into some file, and I flushed out and I closed. Right? Let me run this once. Right? So you can see started object and object serialized. Right? Let's go back. You can see your serialization packet is done. You can see a SCR file, which is serialized file. Let me open this up. See, you can see no, get back because we don't have these files anymore. Let me just close them up. Yeah, you can see this is your serialized packet, right? This is what actually, so in all cases, even if you are using a high-end, very like huge program to convert something, right, it will be converted into this form, right? Where, so this is the buffer where actually you're sending it to your backend, right? So whenever you're sending it to backend, whenever you serialize, this is what is actually being sent right now. So what we have done till now is we have done something called, we have converted our object, which is a FB login, to something else. Now let us say, so this class is nothing but a serialization where you are converting a byte buffer into, sorry, a object into a byte buffer, right? Now let us write a program for deserialization where the next end of program, which means let us say this buffer is reached into a server, right? Now server should get the bytes and should interpret into internal class. Again, how it should do is, it should write a program, we should write a program again, but only thing is we have to write the same class even in a server. This class, this mapping class should be same in both in a client and server, right? Because this buffer is pertaining to something called your CLS FB login. So this class should be maintained as the same in both client and server. Now how do we know that both are same? We use this serial version ID. Let us say you are adding something else, which is public, some string, something called say date is equal to something. Now what does it mean? Your serialization will change. Let us say 2 something, right? So you will change the same class in server and just say 2. So based on your serial version ID, you will have a confirmation that yes, this serializable class at server and client is same because the version ID is the same. So this is nothing but a serial version ID where you're actually maintaining your versions of your class, right? And this serial version ID will also be used in order to actually, while reading and writing, you can also, whenever I write the complete thing, right, obviously it will be saved, right? So we'll see that. Now this is what is something called serialization class, and we used a serializable class. Now let us create a class to deserialize whatever we have serialized. Okay. Let's create a class here. Let me just say serialize, deserialize some class, and let me just write a main here. Now our task is, so till now what we have seen is, we have seen something called output. Output is nothing but you are actually trying to write something into, or you're trying to write something, right? So for writing, obviously we use something called output, right? So now we are trying to do something called, we want to read it. So for reading, obviously if you want to go till bytes, we have to go to till bytes. Why? Because here we are dealing with something called byte buffer, right? So in that case, we have to do something called inputs, right? So whatever we have used here, we use something called input streams here. Now how do we do that? Let's say try catch here and just say systrr of e dot get message, right? So now here yeah, the first thing what you have to check is, so let me take the same file instance here, just copy that, right? So I want to read from this file as such, right? I want to read from this file. So before reading, obviously you have to check whether the file exists or not, right? If it doesn't exist, then just say sys out of file not, or file doesn't exist, right? And just say return, right? So we are just terminating our program here, right? We're just terminating if file is not there. Now if the file is there and everything is fine, then again we have to create a declarative pattern. So what is a declarative pattern we can use? So first we have to use something called object input, because we want to read something, right? Object input stream. Let us say LOBJ object input stream, right? Let us instantiate this over here. is equal to new object input stream. You can see object input stream needs something called input stream, because object will read all the bytes at once, but internally it needs a source where it will read byte by byte and will be fed to object input stream. So that is nothing but it needs an input stream. As of now, what we are checking out is a file, so we need something called file input stream. File input stream, let me just say lobj fis is equal to null over here, and instantiate that over here, which is lobj fis is equal to new, and you can see it needs something called direct source of file. So we'll point it to this f, which is nothing but this f is pointing to a file called fpgeta.serialization. Now this input stream will give it in our object input stream file. Right. Now we are ready with something which is input stream. Right. Now where it can read whatever is being mentioned in our serialization packet. Right. Now the question is, how can we actually read the packet? Or see here, packet is nothing but it's a technical term which we use in general in real time. Packet in the sense one complete object, right? If you are actually sending one message from a client to server, so we call it as a message or a protocol or anything, but basically in technical terms, whenever you are working, you say packet is being sent. Packet, that is nothing but a packet. So that's why I'm taking taking the term called packet here. So right, so the packet is nothing but this class, right? This object, whatever we created, this object over here is nothing but a packet, because in this packet you are filling the items and sending it over, right? So here now our object input stream is ready to read something, but before reading, what we want to do is we want to catch that into some object. So what is that object? Again, I want to get something called FB login object. So let me create this object now. So our intention is not to create an object here, but our intention is to get some whatever is there in this file into this. Now let us say I'll write something called lobjis, which is input stream, object input stream. You have something called read object. Read object will directly read the complete thing being inserted in the file, and it will give it to some variable. Now here I'm taking something called CLS FB login class. Now when I say this, so this will give you complete object. If you see this one, right, read object, you can see here it is actually giving you something called object type. Object type is something which is a higher type, and CLS FB login is something which is a defined type, right? So obviously if you want to convert an object into lower end, what you have to do is you have to do something called typecast. You will understand this typecast when we actually come to typecasting and boxing and unboxing, right? So now what I'm doing is I'm trying to convert this object, and anyways object input stream is reading an object, but we never know what is the type of that object, right? Because we are getting this from some file which is unknown file, let us say, right? So that we are converting it into object here, right? And now what we'll do, we'll just see what exactly is there in it. Let us say sys out. Let me just say, let us just call it first as sys out of started deserializing, some deserializing, right? And we'll just say here, yeah, we'll just say sys out of after deserializing, right? Now after deserializing, what exactly we have? Sys out. So let us print that obj dot something called username here, right? Now here you can see I'm not creating any object of this directly, and even if you create any object, by default you can see that they are null. Now how I'm getting this username and password is through my serializable packet here, and username, and then we have something called password, right? Just fill in that password, right? Now you have written something which is a deserialization process here, where I'm using my object input stream to read the object whatever is being saved in my packet, which is serialization packet, right? And once I'm getting this, I'm reading here. Now obviously we have to do one more thing in here, that yeah, as you have got the object, right, you have to check whether this object is of type CLSFB login or not. Sometimes you may get any other object too, right? Because if you are pointing to some other packet, right, it may happen that you are not getting the right packet. So for that, if you remember, we have something called instance of. Instance of is like you are checking out, you have something called if I is equal to 0. If you want to check, how do? We do something like I double is equal to 0, right? So in the same way, in order to compare two objects, we use something called instance of. Let's say CLS FB login. We are checking whether this FB is instance of. You can see so once you declare this CLS FB login obj, it doesn't mean that you are actually creating an instance. What does it mean? You are creating a variable of your class CLS FB login, but which is giving an instance? Your read object. Your input stream is actually giving an instance. We are just checking whether it is an instance or not. Let me just say, if it is an instance, just say this is a correct instance, right? This is a correct instance, right? And if it is not, just say not a correct instance. Simple word, right? So if everything is fine, it just say yes, everything is mapped up. And if there is something in here, just say not a correct instance and just say return, right? Because if it is not correct instance, obviously you don't have to do anything else here, right? Now, so we'll just run this up and see what exactly we'll be getting this, right? Deserialize, right click and just say run as. Yeah, you can see started deserializing. This is a correct instance. So we read something called from some file which is unknown file where some object is written, because when you are deserializing something, you never know what exactly it is, right? As we have a contract that your FB login will be saved in this file, that's why we're just mapping this object to CLSFB login. So we have checked whether this is the right object. It says yes, this is right object. Now you can see whatever we have saved here is actually getting given here, right? So that is what is a deserializing process, where we're actually reading the buffer from one file and mapping it to the same class, and we are reading the data, right? Now here, whenever you change anything, right, let us say I'm making it as some user, let us say tree, right? I've changed something here which is serializable. Now it is in your client. Let me run this. Now you can see that your file got created, new file which is 659, a new file. Now if you go back to deserialization, run this up, you can see the change tree immediately. Why? Because you are actually persisting all the bytes of your object in something called your file, and you're actually reading the same thing from your file again. So that is nothing but your serialization process and your deserialization, right? And here in this you have one thing. Let us say you have one more thing in here which is public, let us say string, let us say some date, right? Or I can just say like packet date, something, right? So I'm just adding a new variable here, and let us see whether it is serial persisting or not. Obj dot, let me just say packet date is equal to something, let's say today, right? And I'm using the same serialization class, and go to deserialize and just say, just see whether it is been mapped or not directly. Dot, just say packet date, right? So let me run this file, serializable file. It says yep, object serialized. Go back to deserialize and just run this. Yeah, you can see today, right? It is reading from my file and it is converting it is a true conversion here being done, where each and everything will be mapped, username, password packet, each and everything will be mapped up, and it is that's why it is giving each and everything as a character. Now here you may get something that you don't want to do something called so even if you have some packet data, you don't want to make it serializable. You don't want to send this, because why? Because once you are actually serializing a class, right, it is again a costly process. Why it is a costly process? If you actually serialize or convert something into byte buffer which is not needed, if you just create some bytes of which the variables which are not needed, right, obviously you're actually increasing a byte size, which is obviously costly, because you are sending over the network or you are saving a file into your hard disk, right, which is unnecessarily making your processing time, first processing time, and second memory size, third is byte buffer size is being increased, right. And here if you don't want to make if you want to send only username and password, but you also want to have FB login with a packet date, but if you don't want to make it persistent, or if you don't want to serialize, then we use a token or a access modifier called transient. So transient is a non-access modifier, right? If you use this transient whenever you serialize something, right, so this will not be serialized. Here you can see that I'm assigning something. Okay, let us run the same program. I just made something called transient here. What I'm doing in this class, I'm just making a declaration that packet date should be today, and while deserialization, again I'm mapping something. Let us see what happens to this now. Let me create a serializable file. Yep, the object is serialized. Let us go back and see here. Can you see here? It is null. Why it is null? Because by default there will be nothing in here, right? By default there is nothing, and even when you are actually deserializing an object, right, this object contains only two things, which is your username and password. So that's why it gave username and password, and it don't have anything called packet date. That's why it just gave null. So this is how, if you want to skip anything, you can just skip by using something called transient, right? So this is how we do something called serialization and deserialization of a class, right? And I was mentioning about something called, you should always have something called constructor of a serializable class. It should be default constructor and without any arguments here, right? Let's say, yeah, let us say I'm creating something called int a here, right? Where I'm creating something which is, it will give me some error here again, right? Let us say I'm giving a 3 here. Now here we are creating something which is not accepted, right? Let me run this once and go back and run this, right? It gives here. Why? Because this constructor should always be a default constructor. Sometimes what happens, internally it is calling a serializable interface class. We are using only few things which is actually can be mapped directly. But if you are going for higher things where you are actually saving some, let us say 1, 2, 3 KBs of data, and if you don't maintain the direct class of default constructor, right, it may hit you. As of now, anyways, your super will be called. That's why what you are doing is you are actually making use of direct serializable. But always don't do any argumented constructor. Always, if you want to actually create argumented constructor, first define this default and then go for some argumented constructor, which is, you can use the same thing and just say something else which is int a or something. But try to maintain some default constructor where you are giving some default, because for smaller programs it may run, it may call, but the heavier programs obviously it has to call different methods which are in super of your serializable class, right? There you may hit. So that is one thing in here. And yeah, and let us see how we can create a nested classes, how we can create different classes, right, where different classes as such. My meaning is, as of now we have seen FB login. How can I create an object of other class in this, and what happens to that? That is one more important thing what we have, right? And we'll see higher things like if we define cache items in the sense arrays or collections, right? If I define a higher bigger items in here, is that persisted or not, and how it is persisted, and how to fill them, right? And if you are creating nested class of this serializable class, right? And let us see how we can, I mean nested class in the sense, when I create another class and if I define an object here, whether it is being serialized or not, and if it is being serialized, what are the different conditions we have, right? We'll see all these things, and once that is done, we'll be done with our file systems, right? So we'll check out this tomorrow, and once our file systems is done, we'll then immediately we'll check out something called strings first, strings handling, and then we'll take up packages, right? So anyways, parallelly I'm preparing these topics in one of my document, right? So once these things are done, I'll send you the document where you can actually map to your videos, right? Fine, people, so let's wind up here. So you guys have any doubts in here?